There's 5.5. Here we go. We're going to do this stuff. It's going to be awesome. I even told you about it before. All right. So we've got, remember we were talking about that Iowa Basic Skills Test. Oh, no, we haven't talked about that yet. Sorry. Anyhow, each grade has a score equivalent, right? So one means that one means that they are scored, they're at the first grade level, 2 at the second grade level, 3 at the third grade level, and so on. With this particular situation, it turns out that it's roughly symmetric. It's got a center peak, right? And it might actually really be a good candidate for a continuous probability distribution. It fits under a nice smooth curve. And a person can score, right, at 6.4, 6.2, 1.3, right? Like, I guess they're saying like there's 10 months of school. So like a 1.3 is like a first grader in the third month. Like that is what they're kind of saying. So, right, have they said that yet? But I just kind of get an intro to it. We'll have some actually like some things that you need to write down here in a minute. How about writing? There you go. So a density curve has 2 rules, okay? It's always above the horizontal axis and it has an area of exactly 1. It doesn't even have to be a curve. We'll look at a couple actually like uniform distributions that don't have a curve. They're still a continuous probability distribution. Almost like I'm feeling for the swimmers. I'm having like ghost awareness for them. We wrecked them yesterday. They're all sitting on the side of the pool like this. Oh, shoulders. It's a good day. I don't like IM days. That's when they swim fly back breast free, just pretty much for the whole workout. And fly is just rough on the shoulders. So, and my butterfly is real bad. My butterfly stroke is quite atrocious. Okay. All right. So the mean is going to be the balance point of a distribution. So essentially, it's the point where we'll balance, right? Because they're not always perfectly symmetric, right? So if you have a distribution that's not, your mean is going to get pushed towards a balance point. Gosh, I think I played like almost every song that I know. Trying to look at it. I think I only missed one. Jack Johnson song. Oh no, I didn't play that one. I missed a bunch of them. Well, that's it. Just kidding. I'm out. Cool. All right, let's just leave. I know I shouldn't say anymore. I'll be charged with inciting rebellion. always wonder what it would be like to be in high school and be that kid that everybody knows. I wonder what that would be like. Is it as cool as people make it out to be? Maybe not. I don't know. I had no idea. I was not that kid. Okay, so hold on. I'm gonna get you just the stuff that you need, okay? Okay, so what's gonna happen here is if your distribution is perfectly symmetric, your mean and your median are the same, okay? So in this guy, what? That was incorrect. What happened? That was weird. Okay. So, so if it's perfectly symmetric, then mean equals median. They're going to be the same. Okay. If the distribution is not symmetric, okay, you're going to find a tail on it, right? What's going to happen is that the mean is getting pushed towards the tail. And the median is basically splitting the area in half. I know 2 country songs too, Coach.
No way.
Yeah, I do.
And what exactly are they?
They are Help Me Make It Through the Night and Sunday Morning Coming Down. Both Chris Christopherson songs. Don't know why. All right. I know that Help Me the Sunday morning because I can never remember. I'm having the hardest time memorizing the chord changes. They're like different for every verse, which makes no sense to me. You know, how's he still alive but George Michael's dead? Come on. I think there's probably a few reasons. Yeah, there's a few reasons.
There are consequences for your life choices.
Yes. Live fast, die young. Yeah. Hey, yeah. So this is what a normal distribution looks like. Really, this is all we're going to do is just show you what it looks like. It is symmetric, has a single peak. The mean and the median are equal, and they're both the center. We're going to use the mean as a measure of center. And then our standard deviation describes, how wide the distribution is. Should I continue decorating this room? I put up like one thing a week. Put that up. I keep moving books out here. I don't know why. I'm gonna have to put them back in the closet in 8 weeks or something. What do you mean? Oh, they're gonna give me classes to teach. Oh, so what do I do for the rest of the year? Normally, I teach. I do have 2 freshman classes. Not 2 freshmen, but 2 underclassmen classes. I teach algebra 2, so I have juniors. Sorry, I don't know why I said freshmen instead of underclassmen. Normally I would just kind of cover classes when people need coverage and stuff like that. It's one of the fringe benefits of being a senior teacher is that you get done a little early. But on the other hand, I have to send a lot of emails and make a lot of phone calls to parents because it's very important that y'all graduate. And sometimes I feel like Coach Gill and I are some of the few people that feel that way. There are a lot of kids. I should say that's not true. I should say that there are a lot of kids that don't feel that way. We have to help them to realize it is important. So we wind up growing seniors. All right, let's do an example, okay? So it's kind of weird stuff, okay? We're going to say this is a probability distribution. This is a uniform distribution, okay? So I'm just going to put some lines here. First of all, they're wanting to know what is the height of this probability distribution. Okay, so what we're going to use is the idea of the area. Remember, we wrote down that the area underneath the curve, if you will, this one's a straight line, it should be equal to what, right? We also know that area is equal to, well, it says height, but let's say length. I guess we could go length times height. If they're saying calling it height, right? Okay, so then we know that 1, right, our area is equal to, what is our length? 3,600 times the height. So then in order to figure out what that height is, we'll divide both sides by 3,600, and we get that the height is 3,600. Okay, what is the probability that the request is received within the first 300 seconds, 5 minutes after the hour? So we can represent this probability as an area, right? And that's what we're going to start doing. We're going to be representing probabilities as areas under the curve. So I think I would like to split this thing up into maybe 300s, I guess. I don't know. Does that make sense? Let's see. 4, maybe 4. We'll go by 900s. So I'll split it up like that. 1, 2, 3. And that would mean this is 900. This is 18. And this would be okay, they're wanting to know the probability it's received within the first 300 seconds, 5 minutes. So 300. So that's going to break this up into so what we're looking for is the area of that shaded region. That's going to be the same thing as the probability, okay? So we're going to say this probability. Okay, what is that going to be? Well, it's length times height, right? Right, area, or in this case, length equals length times height. Well, we know that we already know what the height is, right? The length is 300, and the height is 1 over 3,600. So what is that? That's 300 over 3,600. 3 goes into 36 12 times. That is the answer to number 3. All right, what is the mean of x? It is the center, right? So, or we could say mu sub x, I think. Yeah, my bad. We'll use some. Why? It's symmetric, right? And that's the middle. And that's going to be the same reason for both of them, right? Because the distribution symmetric. And the median is also 1,800 for the same reason. Basically, you're gonna have to do a very similar problem, and it's a weird problem, but I think when you grapple with it, you're gonna understand what we're doing, or we're about to do with normal distributions, right? We're gonna represent probabilities as the area under the normal curve. So I think this is kind of just gets your brain really comfortable with that concept. That's why I like this.